Hello, myself Kinjal patel. Welcome to my channel Basic of Mathematics. Today our topic is irrational number. This is the topic of chapter 1 of standard 10. Now what is irrational number? Those numbers whose decimal expansion is not a exact decimal value. This type of number is called irrational number. And for proving a given number is irrational or rational, you should be use this theorem. And this theorem statement is let P be a prime number and P divides by any number square. Then P divides a number itself. We better understanding by taking one example for this statement. If you have this a square, that means 10 square. Ultimately it is 100. And 100 is divisible by a prime number. So you should take suppose 5 or 2. If you want to take 2, then 2. 100 is divisible by 2. That implies 10 square is 100. So 100 is divisible by 5. Then itself a number, that means 10, because A is our 10. So 10 is also divisible by 5. Yeah, 10 is also divisible by 2. That's why this statement say P divides A square. That implies P divides A. Or A square is divisible by P implies A is divisible by P. Both meaning are same. Now, to consider this statement for this proving root 5 is a irrational number. So, for proving root 5 is an irrational number, we should take here method of contradiction. Method of contradiction, that means we supposed to take this is a rational number and its condition we write here for rational number, and after some step I proved our suppositions, our condition is wrong. That's why this is a irrational number, because in our word any number is included either a rational number or irrational number, not a both. That's why you supposed to take this is the rational, that is it is not irrational, and that is a irrational, so that is not a rational. So here suppose root 5 is a rational number. Therefore, root 5 is equal to, you can write rational numbers. So, rational number presentation is sum numerator and denominator, and GCD of numerator and denominator is always 1. This is the symbol of GCD. So, here you can write root 5 is equal to A by B, because we suppose this is a rational number. Now, you can, this division here become a multiplication. So, root 5 into B is equal to A. For removing square root, take square both sides. So, root 5b square is equal to A square. So, this become a 5b square is equal to A square. So, you can write b square is equal to A square by 5. So, what this denotes? A square is divisible by 5. That implies A is divisible by 5. So, that implies A is divisible by 5. Our theorem 1.3. So, A is divisible by 5. That means A is a multiple of 5. So, here you can write this is that implies you can write A is a multiple of 5. That's why we should write here 5 into some constant. This is 3. Use 3 into. If you want to write here, write A is multiple of 5, because A is divisible by 5. That's why A is equal to 5. This is 3. Now use 3 into. How? By putting value of A. So your 5b square is equal to, instead of A you should be write 5k. 5k square. So 5b square is equal to 25k square. Now change side of this. So you can write b square is equal to 25k square upon 5. So b square is equal to 5k square. This meaning what? B square is a multiple of 5, because 5 into some constant Here k is your constant. Constant means any numerical value. So this indicates b square is multiple of 5. Therefore, b square is divisible by 5. That implies b is definitely divisible by 5 by theorem 1.3. So you can write b is divisible by 5. Therefore, b is a multiple of 5. That's why we take 5 into k, yeah, k dash, where k dash is your constant. This is gives 4. So by 3 and 4. A is multiple of 5, though 5 k. B is also multiple of 5, so 5 k dash. So what is the smallest factor of A and B? A is multiple of 5, so which is starting from 5. And B is multiple of 5, so definitely starting from 5. So HCF of A and B is 5. But according to our supposition, its HCF is what? 1. HCF or GCD, both are the same thing. Its GCD is 1. So, which is contradict our supposition. What is our supposition? This is a rational number. That's why root 5 is an irrational number. By this way, you can prove any number is an irrational number by method of contradictions. Let us consider one more example for proving this irrational number. Second example. Suppose you want to prove that 2 plus root 3 is an irrational number. So how we can prove this? 2 plus root 3 is an irrational number. So let 2 plus root 3 is rational number. So this is our supposition. So you can write 2 plus root 3 is equal to A by B, where GCD of AB is equal to 1. Now, root 3 as it is, you should be right, change the sign of 2. So, root 3 is equal to A upon B minus 2. You can write this is 2 by 1 also. So, root 3 is equal to A, take LCM of B and 1 is B. So, here multiply by 1 and here multiply by B. So, we get root 3 is equal to sum P by Q. This is supposed to take, this is all P and this is a Q. So, its LHS is a root 3 and we know root 3 is an irrational number. This is fact. And P by Q formation is definitely a rational number. So, you can write LHS is equal to root 3 is irrational number. This is fact. And RHS, it is form of P by Q. So this is a rational number. And earlier I told you a number is either is a rational or irrational, not a both. So this equivalent condition is false here because we prove here LHS is a irrational and RHS is a rational. Therefore, our supposition is wrong. What is our supposition? This is a rational number. That's why 2 plus root 3 is an irrational number. One thing remember always, whenever this type of example coming for 5 marks. So first of all, you want to prove that this is an irrational number by using our previous method and then applying this method. So in 5 marks, you want to prove that this is an irrational number. And one more thing, addition and subtraction of a rational with irrational is always an irrational. And multiplication and division also a rational with irrational is an irrational number. Thank you.